Hello, in this video, we're going to start the new section, 6.2, Real Applications of Normal Distributions. In this section, we're going to be dealing with normal distributions that are not standard. That is, we do not have a mean of 0 or standard deviation of 1. And the key is we will use the z-score formula learned in a previous chapter to convert any normal distribution into a standard distribution. Recall that the z-score, z, is equal to the data point x minus mu, which is our mean, divided by sigma. And because we're going to be dealing with the standard normal distribution chart, we need to round our z-scores to 2 decimal places. That's going to become important. What this will do is it will allow us to what we call standardize, or convert any normal distribution into a standard normal distribution, right? We're going to take a non-standard distribution with any mu and any sigma. So given that data point in that kind of normal distribution, compute our z-score and translate it, almost like we would translate one language into another. And what will be consistent is the area under the curve in any normal distribution will be translated perfectly into the area under a standard normal distribution as long as we follow our z-score formula. Below is our procedure for finding the areas with any non-standard normal distribution. We want to sketch our normal curve and label the mean and aiding data points just like we would. We want to shade in this region. What we're going to do is create a picture of our non-standard normal distribution. What that will do is it will allow us to use the normal distribution in terms of the z-score and translate this. Right? We'll be able to draw then a standard normal distribution picture. And what we'll do is we will not use technology, but we'll use our normal distribution table to find the area of the shaded region in the standard normal distribution. Right? And the area we find will still be the desired probability we are searching for. Okay, let's do an example of this. The heights of men are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8 inches. We want to find the percentage of men who are taller than the showerhead at 72 inches. What we want to do is we want to think about what is our mean in this case, and what is our standard deviation, and what is the data point we're trying to figure this out for, right? Our problem says our mean is 68.6 inches. Our standard deviation is 2.8. That means our data point is the 72 inches, right? Just like with the normal distributions before, we're going to create our normal distribution. Now we have a non-standard normal distribution. Our mean is still in the middle, and I want to plot our data point of x. And because 72 is larger than 68.6, I can approximate its location about right here and put it there. And we are looking for the percentage of men who are taller than 72 inches. That means I want the heights in this shaded region, right? All the heights that are larger than 72 inches. Okay, we have our picture, and now we want to convert to our standard normal, right? So to do that, we need our z-score formula of x minus mu over sigma. So our z-score is going to be our data point of 72 minus our mean of 68.6 divided by our standard deviation, which was 2.8. If I compute that and round to 2 decimal places, I'll get a z-score of 1.21. That means is when I have my normal distribution of mean of 0, that point of 72 is going to correspond to a normal standard distribution of a z-score of 1.21. So I want to compute the area here under this curve. I want to find the probability that z is greater than 1.21, right? Using that notation that we learned from section 6.1. And if we recall, our table A2 only would give us the probability that z is less than 1.21, right? The probability to the left. And so what we want to do to find our actual probability is do 1 minus that probability value. So let's look at what that z-score is going to be. Okay, we have our positive z-scores on our table A2, and I want the z-score of 1.21. So I look at the 1.2 row and the 0.01 column, and I'll look down and across, and I get my answer right here of 0.8869. Okay, so we found that probability. So I can get 1 minus 0.8869 and give me an answer of 0.1131. Now problem asks, what's the percentage of men taller than 72 inches? So we get the percentage as being 11.31%. Right? All we have to do is just take our z-score formula, convert these data points into a new z-score, and compute exactly what we did in the previous section. Reading the table, determining whether we want the area to the right, like in this case, an area to the left, or an area in between two values. Hopefully this was helpful. If you have any questions, feel free to email me. We can Zoom other examples. If you want, I can post other examples online. Just let me know, and I'll talk to you next time.